As we continue our deep dive on Mars, we're going to be looking more at the science side. And in this lesson in particular, we're going to be looking at the scientific evidence for water on Mars. Now, all of this is kind of still pointing towards that persistent question of life on Mars, but from a more scientific angle. So let's walk through kind of the evidence for water on Mars. So the first evidence is really simply visual and kind of obvious. All right. Now we have these incredible orbiters that are taking these pictures of the surface of Mars, mapping it out in incredible detail. And if you look at an image like this, and we can explore even Google Mars in more detail here, but you see what just anyone would look at this and say it looks like a river channel. I mean, it looks like a delta, like a flow of water out into a low region, right? You've got the higher area in green and yellow, the lower area in blue, and it sure looks like fluid is flowing through there, right? So the question becomes, is that water or is that some other fluid, right? I mean, that's a legitimate question. Now we see that not only in that spot, which you can see is right here on Google Mars, we see that in lots of other places, right? Where you would say, oh, it looks like fluid flowing, and you could say there's, what are these streamlined islands, we call them, right? Let's see if we can find a good example of a streamlined island. Well, certainly right here. In fact, if we switch to be more detailed imagery, oh yeah, look at this. Doesn't it just look like fluid is flowing around all that stuff? Hello, there it is. Okay. But the question becomes, is this water or is it some other kind of fluid? Is there some chance this could have been like a lava flow or something like that? Maybe that's what's causing this particular shapes. And in particular, why it's kind of so hard to believe that it could have been water that is causing this, right? It's like, well, what's the big deal? If it's water, it's water. The reason it's kind of hard to believe is illustrated in this video I want to show you. And it all comes back to the fact that Mars is much smaller than the Earth. It has very little atmosphere, and because of that, the atmosphere is very low pressure, right? So as you climb a mountain, pressure gets lower and lower and lower, right? And so what impacts that is lower pressure means it's easier to boil water, to convert water from a liquid to a gas. Now, when we think about boiling, we usually think about it as it's because of the temperature, because something is so hot. That's what causes it to boil. But really, that temperature is heavily influenced by the temperature at which something boils is heavily influenced by the pressure of the air around it. So you probably haven't, but maybe you've heard of the idea that you could boil water on top of a mountain at a much lower temperature than you do at sea level. Now that's illustrated in this cool little experiment. So what's here is a flask of water. Okay, and it's at room temperature. You can see the temperature right here is about, this is Celsius, 45, okay, Celsius. Actually, that's not right. That's probably Fahrenheit. It's probably like cold water, refrigerator water, okay, 45 degrees Fahrenheit. And what they're doing is they're putting it in this bell jar, and this is how you create a vacuum. He's going to turn on a pump, and you'll probably hear it, okay? And what it's doing is it's sucking the air out of that bell jar. Now check it out. This is the temperature of the water is not changing. This is cold drinking water. All right. But watch what happens when the pressure is dropped far enough. Whoa, you see that? Bubbles. It's boiling. This cold refrigerator water is boiling, and even look at that. It's steaming up inside the jar because it's boiling. So the point here is that if you had liquid water on the surface of Mars, the pressure in the Martian atmosphere is so low that the liquid water would instantly boil and evaporate and become steam, essentially, and then drift away from the planet, escaping the atmosphere. So there's really no way for liquid water to just sit there on the surface of Mars, even though it's super cold, right? That's why with the Phoenix lander we saw that the ice that was there when it dug under the ground and there was ice, it basically just evaporated directly, right? Because when a tiny little bit melts, it essentially just evaporates into a gas. So it doesn't just like melt like ice and turns into a liquid. So we see why it would. So it makes us wonder, well, how could there have been water? So then it makes us ask more questions. Well, what other evidence do we have that suggests it might be water specifically as opposed to some other fluid? So one of the other sources of evidence actually comes through spectroscopy. So with all these orbiters, we have lots of scientific instruments. What they can do is they can take spectra, where they're actually looking at the precise wavelengths of light coming from the surface, and that allows scientists to determine what types of minerals there are on the surface of Mars. So here's an example. This is a map of the iron on the surface of Mars. All right. So there's a map showing there's a hot deposit of iron in this spot, and there are other places where there's much less iron. So you can start to tell something about the history of the planet if you know how these minerals are distributed. So here's a similar map, but this is a map of water concentration, right? So this would be water in the form of like frost and surface ice. Okay, so again, the spectral signature shows these areas where there are hot spots. In fact, the colors are inverted in this case, so the blue and purple is where there's more, and the yellow and red shows where there's less. And you can see the most is here on this polar cap, where there's actually like a water ice cap. And you see, it kind of makes sense, I suppose, that there's less around the equatorial region of Mars. Okay, so we can actually see spectral evidence of at least some form of water. Not liquid water necessarily, but frozen water on Mars. So we know that the molecules of water exist and are there. Now there are other types of evidence though too. There are these things called blueberries. Okay, blueberries. Now these form on Earth and they also form on Mars. And what they are, they're these tiny little like iron concretions, they're called, like little iron balls, little iron BBs. So it's like if you were going, just imagine walking through the desert and then you just stumble upon an area where you just see all of these little spheres. I mean, just sitting on top of the surface. You'd look at this and you'd be like, well, is this like fossilized rabbit, droppings or something? What's going on here? This is a totally geological process. What happens is a liquid comes into a porous rock material, and that liquid dissolves and carries with it all kinds of minerals like iron. Okay, let's just focus on iron. Carries with it dissolved in the liquid, so you get this liquid like a water that's very irony. Okay, lots of iron in the water. And what happens then is that gets concentrated, and then there's a little seed almost where a little bit of iron is sitting in that rock, and then all the iron kind of wants to be around it. And then as that rock dries up and the water goes away, the iron that was evenly spread throughout the rock has now been concentrated into this little sphere, a concretion. So then you get this rock. I wonder if there's an example of this. A rock. So you have a rock that has a little sphere of iron in the middle of it. But over time, these rocks erode. There's all kinds of geological processes at work. And as the rock erodes, what's left over is the little sphere of iron. So you find these on Mars and on Earth. And in fact, some of them can be absolutely enormous. Check this out. Look at those concretions. Pretty amazing. So what does that tell us? What it tells us is that at some point in Mars's history, there must have been a liquid that was permeating these rocks in order for these concretions to form, right? And water is kind of like the ultimate solvent, right? Because so many things can dissolve in water. That this at least suggests a wet history on Mars. Now, other types of liquids could also be solvents in this way, but this is pretty striking evidence in light of everything else that, in fact, there was a wet history on Mars. So I show you this to illustrate there is more than just these pictures of like streamlined islands and what appear to be river gullies. There are lots of different kinds of evidence all pointing in the same direction. And then of course, here's the ice cap. Like we know it's there, right? These are actual photos in some cases here. This is a real photo of the liquid water ice cap on Mars. Okay, and then we know there's ice with the Phoenix lander. I've already showed you that. See, here's the comparison. We know right underneath the surface. And then we have much more recently, this is in the past year of when I made this video, evidence of liquid water sort of emerging from underneath the surface, right? So we have evidence of historical water on the surface of Mars, but we also have evidence of current water on Mars that is released in flows, okay? So temporary flows of water. So this is like a three-dimensional rendering based on images, I believe, from the Mars Reconnaissance Orbiter, right? Which show these dark streaks where, what does it say here? They're inferred to have been formed by contemporary flowing water, all right? So contemporary meaning presumably recent flowing water. So new findings from the Mars Reconnaissance Orbiter provide the strongest evidence yet that liquid water flows intermittently on present-day Mars. So these dark streaks, I believe I showed you a picture like this before where you saw like a dark streak and a light streak. And so by comparing these orbiter images, we can see these changes to when water may be flowing. So you can imagine in this kind of environment, if you have ice beneath the surface in all this area, right, and you have the sun hitting it continuously, you could have a warm spot, some of it melts, it breaks free, and you have a small flow, it quickly evaporates, etc. All right, so we see this strong evidence of water on Mars. Okay. In terms of why we care, we're going to get to that in later lessons, but again, it's all pointing towards that picture of life on Mars, not in the sort of War of the Worlds sort of alien way, but in terms of a much more scientific pursuit of the question of, does life exist anywhere else in our universe besides the Earth? Okay, I will see you next time.